One of the most important things to have in a physics classroom is a good problem-solving approach. And what I'm going to explain in this video is the way I go about solving problems. If you apply this technique to working out your problems, you'll probably find it works a lot better than just kind of randomly trying to work your way through things. As someone who is brought up and educated as a scientist, I've been taught to think about things in a step-by-step approach, a very uniform way of looking at things. That's what the scientific method is really all about. It's a step-by-step, very systematic way of solving problems, of answering questions. And we can apply a similar type of approach to our problem solving, where we take it one step at a time, thinking through a number of things in a specific order to get our way to a solution, to get our way to the end of a problem. Now, this problem-solving approach is the way that I think about problems. Some people think about things differently. You may develop your own problem-solving approach of your own as we work through the course. But this is a good starting point. This is a good jumping-off point. And every time that I do a problem in a classroom, I will use this same approach, again, to keep it very uniform. It's got 6 steps, but these are just simply 6 things that I do or think about whenever I'm trying to solve a problem. The first thing I do is identify the numbers that are given to me in the question. I read the question and oftentimes simply just look at the units to figure out what each of the numbers in the question mean, what they are, what variable they will represent. And I make a little list of them. D equals, T equals, B equals, whatever the case might be, whatever variables I'm working with, I make myself a list so that I can reference them while I'm working on the problem. Next thing I do is look for hidden numbers. Now, what is a hidden number? What happens a lot of times in physics is there are assumptions that are made. For example, anytime you're dealing with falling objects on Earth, the acceleration due to gravity is 9.81 meters per second squared. So I can assume that number without being given that number. So oftentimes when I have to use it, it's not written in the question. I'm just expected to know that and add that to my list of givens. In terms of motion, I might read a question that says a car comes to a stop. Well, what that's telling me is that the final speed of my car or final velocity of my car is going to be 0 or coming to a stop. Again, it's not written in the question as a number. It's kind of hidden in there. So that's what I refer to as hidden numbers. And anytime that I can identify one of these hidden numbers, I add them to my list. Next thing I do is think about what I'm trying to find. What's my unknown? I mean, there's no sense in trying to solve a problem if you don't know what you're trying to find. So I always write that down. I always list what my unknown is, what I'm looking for. I identify what equation is going to get me there. So I will look through my list of equations. And, early on in a physics class, there aren't many. But it doesn't take long, a few weeks, and before you know it, you've got 8 equations to choose from. So I'll look through my set of 8 equations, and I'll try to find one that will get me my answer. Now, oftentimes, I'll be referencing back to that list that I came up in steps 1 and 2, looking for the equation that has those variables in it that will give me my answer. For example, with velocity, by the time we're done with motion, we're going to have maybe a dozen equations that have velocity in it. That might be an overestimate, but a lot of equations that have velocity in it. And there's only going to be one that's going to get me my answer. So how do I pick from those? I look at that list I made. I look at those variables that I identified, and I'll try to pick the equation that has those variables specifically in it. I look for missing information in my equation. I'll look to see if there's something I need that I don't have in the list that I made in steps 1 and 2. And I'll try to find a way to get it. And then only after all that thought, only after doing all those things will I substitute and solve. I don't pick up a calculator until I've got a plan. That's the bottom line. There's a certain group of students that I've always taught. I call them button pushers. I call them button pushers because anytime they're given a problem to do, the first thing they do is pick up a calculator and start mashing buttons. They start punching buttons until they get something that looks reasonable, or worse yet, on a multiple choice test, they start mashing buttons until they get something that matches one of the answer choices. Doesn't usually go very well for button pushers. you got to put some thought into it first, either in your head or on paper, to make sure that you know what you're going to do with that calculator before you ever pick that calculator up. That's how you avoid being a button pusher. So let's take a look at this problem-solving approach in action. And I'm just going to use a very simple equation, one that you probably learned back in middle school at some point, the speed equation. A runner completes a 50-meter race in 7 seconds. What's their average speed? So again, the first thing I do is identify the numbers that I'm given in the question. And there's two numbers I'm given here, the 50 meters and the 7 seconds. Now, I know I'm doing speed, and speed is a scalar quantity, which means that these numbers with meters on them are going to end up being distances, not displacement. So I know I've got D. D is 50 meters. The other number I've got is 7 seconds. Seconds measure time. So I know I have a T. I know D is 50 and T is 7. And I just list them just like that on a piece of paper if I'm doing it on paper, on a board if I'm doing it on a board. And that's all the numbers that are in the question. Now I ask myself, are there any hidden numbers? And this doesn't have any hidden numbers in it. It doesn't say anything in here about a thing coming to a stop or starting from a standstill. Nothing's falling. There's nothing that strikes me as hidden numbers in this one. So that is my complete list. Now I want to find what it is I'm looking for. What is their average speed? And I write that down. S equals. I want to figure out what S is. Oftentimes I'll put a question mark in there to recognize that that's my variable. So that's what I've got. Now I think, what do I have in my list of equations that would give me speed? And there is only one equation that has speed in it, and that is the speed equation, S equals D over T. Velocities are used a lot more in physics, so you would have a lot of equations with V's in it, but there really is only one equation that has S equals D over T, and it works great, because when I look at this equation, it's got distance and time in it, and those are the two pieces of information I have. There's nothing missing here. That equation can be used just the way it is to solve my problem. So at this point, I'm ready to substitute and solve. Speed equals D over T, so it's 50 meters over 7 seconds, or 50 divided by 7, which I didn't calculate here apparently. And I don't have a calculator anywhere near me. So grabbing this calculator, divided by 7, 7.14. Go back to me. Oh, that's why. 7 in the unit would be meters per second. So there you go. That's using that uniform problem-solving approach and trying to figure out how to solve a problem, basically. You know, given nothing in the context of the question that tells me how to do it, figuring all that out on my own. That's physics, and that's why so many colleges like to see physics on transcripts. Let's do another one. A hiker is walking in the woods. The hiker travels 5 meters north, then 16 meters west, and then 3 meters north, and finally 7 meters south. So this sounds a lot like one of our distance and displacement type questions. If the walk takes 90 seconds, what's their average speed? So again, I'm going to go through this, and the first thing I'm going to do is identify all the numbers that are in it. So 5 meters, that's either a distance or it's a displacement. Because we're dealing with speed here, I know it's going to be distance that number represents, that number is going to give me. So my first distance, I'm just going to label it D1, is 5 meters. Now note, I didn't put the north on it. And the reason I didn't put the north on it because it's a distance, and direction doesn't matter. 16 meters west, that's going to be another distance. That's D2. 3 meters north, that's going to be another distance. And 7 meters south, that's going to be a fourth and final distance in this one. So I have 4 distances. that I'm given in that particular question. The 90 seconds is time. So I have a t there as well. So I have 4 distances and I have a time. What am I trying to find? I'm trying to find average speed again. So there's no hidden numbers in there, just like last time. It's not talking about coming to a stop, starting from a standstill. Nothing's falling. There's nothing in there that screams to any hidden number. So that's what I'm given to work with, and I'm trying to find the speed. Like I said, there's only one equation that actually has speed in it. Speed equals distance over time. S equals d over t. Now, I need to know distance. So I have to go back to previous concepts, previous ideas, something that happens in physics all the time. And that's where the problem-solving approach is really going to come into play. Because when I look at this equation, I see that d there, I really don't have d in my list. I have 4 of them. And I've got to know what to do with those. So being that this is a distance problem, I simply just add those all together to get the total distance that my object moved. So the 5 meters plus the 16 meters from the 3 meters plus the 7 meters gives me a 31 meter total distance. So again, not uncommon at all in a physics class to have to go back to previous concepts to answer the new question. Some problems might take you 2 minutes to go through because they're simple single step problems. Some might take you 20 minutes to go through because you're figuring out all the steps you have to follow. You're going through a bunch of calculations just to get what you need to solve the problem. So this is physics. And again, that's why so many colleges and universities love to see it on their transcripts. At this point now, I can go ahead and substitute and solve. S equals d over t. So it's 31 meters over 90 seconds. Cross your fingers, and I calculated it this time, and I did. 31 divided by 90 is 0.34 meters per second. So again, that's how I solve problems. That's my problem-solving approach. Hopefully, you can apply it, learn it, and become better at solving problems like this because really that's what physics is.